Run it up, run it up, run it up. Run it up, run it up, run it up. Run it up, run it up, run it up. Going Air Max when I kick shit. Don't dare last but big shit. This Mirror Max, don't be a bit, just be a crap. Steer tracks like engineering. In the sound department, I'm a visionary. This bank shit, I hold accounts and you, beneficiary. I'm a missionary in the right position. I'm a day one, you a late one. Your day's done. Room for mistake, there ain't none. You click pictures, I'm a paid one. You need help, I'm a dominator, an abomination of how is nature. Half damage, flip a coin, now bite the bullet or disappoint, you're gone. I'm a magic man, when I pull up on a record, it's a classic fan. Evil temple like Megatron with devil's horns, got manic plans. Pump up the cavalry, bumping my team, running the town and run up in my team. I'm working the night and you're dead in your sleep. My gang of lions in a world of shame. Yeah, they're blowing up my text. The feeling is T-Rex. When you know that you're the best, let a motherfucker flex. What is next? I don't know, but I'm on my fucking flex. On my fucking flex. On my fucking flex. Hey. Kill a couple motherfuckers, double up the bodies. Kicking in the door, I'm biggie with the army. Bad boys sipping liquor better than Iraqis. Fucking up your life, never really sorry. Die in the streets of my city, no pity. I'm leaving your sword feeling giddy. Head spinning, I'm winning, I'm grinning. This year to year, smile, be no mind, I'm greedy. My versatility like a cheetah's agility. I'm drunk. I randomize my mobility and my accessories. It's fun. If you think about me or speak a word that ain't right, you're gone. Beat you up like a drumstick, punch, punch, kick, leave you dead around and I'm gone. Sad that a motherfucker lost his life this way, I'm gone. Mad that a man with a plan needs stripes to be paid, you're wrong. My West bloody like I'm raw, Shack red spots. I ain't got much, need more cash, it's on. Yeah, they're blowing up my text. The feeling is T-Rex. When you know that you're the best, let a motherfucker flex. What is next? I don't know, but I'm on my fucking flex. On my fucking flex. On my fucking flex. Hey.
Okie dokie. So. What's up, dudes? Hopefully that was fine. Most people, if no one's watching this live, so they can just skip ahead. What's up, dudes? Some cool stuff. Some cool stuff to share. I heard about this paper today by Boringer et al. Unveiling the largest structures in the nearby universe. Discovery of the Quipu superstructure. So let's just look up Quipu. Because it's Kipu. Named after this, an Incan quipu, recording devices fashioned from knotted cords, historically used for various cultures in the central Andes of South America, most prominently by the Incan Empire. Fiber cords, categorized information based on dimensions like color, order, and number, etc. I haven't looked into this. I'm sure it's interesting. Wow, this page is really long. So, that's what they named it because it's kind of threaded. There's threads of galaxy clusters threaded together is the idea. Bunch of Gravity songs. As a result of this, I thought it would be apt to search for Gravity. So that's what we're doing. With that Mongolian one because it was cool. I thought I'd put it there. So, this is probably going to be way more boring than the music. Because I'm going to basically just live read it, I decided. I haven't really looked at it. So, before we go into it, if we go to my videos and just go sort by date this way. Ignoring that one. Which, I guess I published beforehand. Crazy. My generally first video, in a scientific nature, more so. This one, which I haven't looked at in forever, published 10 years ago, January 24th, 2015, where I was saying where this all began. Where this began is really this video and the paper associated with it that's on my website. That's really like the infancy of my work. Nothing is like concrete at that point or solidifying into anything of like absoluteness. There's certainly some things that are, I guess maybe, now that I said that, kind of lasting. But it started with discussion of redshift and the interpretation of the Big Bang, and basically saying, well, there was an assumption made because gravity can cause redshift, so it's an assumption that it's Doppler shift over gravitational redshift. And the critical thing of this assumption is gravity doesn't require the object to be moving, it requires gravity. Whereas Doppler shift is a function of motion, so by interpreting it initially to be a function of motion, it became easier to transition from Doppler shift to expansion of space, and not exactly Doppler shift, but this other thing that behaves basically the same, even though it could have been gravity all along. So it began with this, where I basically said, well, let us hypothesize that there are things that we know of: moon, Earth, sun, supermassive black hole at the center of a galaxy. And then I went on to say, if we extrapolate this pattern, there's no reason for the pattern to end, so we can go to infinity and infinitesimal. And when we go to infinitesimal, the infinitesimal approach infinite abundance, so that there are many, whereas when we go to infinite, it approaches one thing, so there's one thing. And then I said, well, we know that neutrinos can pass through the Earth, and mentioned different types of orbital patterns, a generally circular / elliptical orbit of like the moon around the Earth around the sun around the supermassive black hole, at least indirectly. And then a comet is more elongated around the sun, where there's relatively larger mass differences, is what I'm kind of pointing at. And then I go on and say, well, let's suppose that there's a sufficient mass difference that it basically yields motion around what I at that point interpreted to be the great attractor. I'm not like completely sold on this, although maybe there's something to it that's related to larger scales. I'm not sure where this thing is in relationship to some things we're going to talk about in these papers today. But basically, if light were to travel in a figure eight like this, it would move with a radial motion away and a radial motion towards that are equal and opposite, so it would cancel in redshift terms. But then it would always have orbital motion away to move to the other side of the loop. And so it would have redshift per distance without added complexity of expansion of space, which was just kind of assumed into existence. There was no real basis. It's like, because Doppler shift exists, that doesn't mean expansion of space exists. They're really unrelated. It's just we have assumed that this thing exists and behaves similarly to something we do know that exists, that we observe. And since we can't explain the redshift by motion, because it breaks the laws of physics by things going faster than the speed of light, and we have pretty much not investigated gravity fully, we could not envision the potential where light is being gravitationally lensed like this, which is interesting because where I heard about this from Anton, I am a wonderful person. Meaning I watch Anton sometimes. But Anton was talking about, in, let's see, history. In this one. Oh, I thank you, ads. In this video. About this structure, and I'm not gonna play it. I don't know where he said it. He mentioned something about gravitational lensing, which is what is happening to bend the light is lensing by the gravity of the central mass, whether it's the great attractor or not. The exact system is hard to determine. Looks like I left my phone on. I was watching the intro so I could time it while I was outside. I was like, I'll come back in. But so then at some point in this discussion, my work turns to Corto et al., who have these things. This is them as well. As just something I'm referencing and bringing up as evidence. This is some more of theirs. Structure that I am suggesting has a lensing element to what is going on, perhaps in the filaments. I don't know, but in the least in the galaxy clusters back here. 4 of them that are being lensed. Here's generally where the great attractor is. Here's the Milky Way. So generally across, looking at this, we see what I propose to be an Einstein cross of some galaxy cluster behind this that we're then seeing 4 of because of gravitational lensing. But it's on such a large scale that we have not actually realized that this type of scale of lensing is happening, is what I was proposing. Some of these things, it seems, are going to require more evidence to really investigate further because of anomalies that need further explaining. And I've largely just moved on from this aspect of my research. That was weird. Principle of correspondence is very important. The across the layers, the same things occurring. So this actually really matters with what we're going to look at because it's on a different scale. But that doesn't mean it doesn't behave the same. Just on a different scale. So what I'm exempling here is that a galaxy has a central mass. A solar system has a central mass that we call the sun, whereas in a galaxy it's a supermassive black hole. And then the Earth has a central mass, Earth. So all 3 of these systems have a central mass. How we see them is not the same, but we also are relatively different masses to each of them. So that may be relevant because our building blocks are relatively subtler compared to the mass of a galaxy versus the mass of the Earth. So we may have a proper ratio of our mass to the Earth to actually see it as a planet. Not meaning that it is a planet, but that's just the appropriate building block ratio of the observer building blocks to the observed, whereas the same building blocks have a different mass ratio to the sun. So it basically transitions because there's an infinite spectrum. Essentially, like modern science would say, well, there's planets, there's stars, but then there's atoms, there's quarks, and all these things are divided into separate things. Never mind that quarks are hypothetical and or theoretical, whatever you want to say. Never observed, but never mind that. What was I saying? Across scales. Whatever I was saying is happening across scales. So if we look again, a galaxy has the orbiting mass of the disk, generally speaking, of the galaxy. The solar system has not just the asteroid and or the planets, but also the asteroid and Kuiper belt, which make up big, like, if we look at like solar system, Kuiper belt. So like Neptune, Uranus, Jupiter, Saturn. I guess Earth is maybe here. So there's or no, that's the Oort cloud. So there's a ring here and a ring here of material. Kind of like a nucleus. And a outer ring, like a shell. Now, this does not look like a galaxy. But, again, we are using atoms to observe it. So if we look at it in terms of this, the heliospheric current sheet, surface separating regions of the heliosphere where the interplanetary magnetic field points toward and away from the sun. A small electrical current flows within the surface, forming a current sheet confined to this surface. The shape of the current sheet results from the influence of the sun's rotating magnetic field on the plasma in the interplanetary medium. Where's like the comparisons? They're obviously comparable. It looks like a galaxy because it is one. Just fractally so. Which, one argument against this is, well, black holes are singularities, or whatever modern science interprets, but that assumes that they're not so massive that they just gravitationally lens subtler particles, light, visible light, back to them. But then when we look at black holes in the X-ray spectrum, like Cygnus X1, I'm like, whoa, I'm remembering certain in the X-ray. We see a photosphere, basically, and a radiating system, because it is one, just like everything else. It's just, it lenses by its mass a light back to it, as does Earth, which is why it has a magnetic field. It's just that light is in the visible light spectrum because of its mass, whereas ours is so subtle that we won't even term it light. We would term it ether, which is what the magnetic field is essentially composed of, is subtle particles that are trapped in the gravity of this relatively infinite system, Earth. Gravity and physically traveling as a function of its rotation in a magnetic field as essentially infinite particles, all collectively working together to make a magnetic field. And then some other parallels. Earth has infrared radiation, where it radiates in infrared spectrum, so it's just like an octave down, basically. Visible light radiation, air glow, where the sun or the earth actually, like the boundary, it's not like the earth glows and glows less and less and less. There's actually a boundary where the earth glows called the air glow of the ionosphere, which is the equivalent to a photosphere, and then solar flares and sunspots, equivalent to upward lightning sprites and elves through the disc. Sprites through the disc of the elves. So Earth has the same types of mechanics going on, just different in appearance because of how we see things based on our relative building blocks. But because there's an infinite spectrum, what building block an observer is, or a group of observers, us as on planet Earth, composed of the relatively same building blocks, so that we all are like on the same dimension and in the same octave of the infinite octaves, which then literally creates the way we see our surroundings as a function of our own building blocks. It's not separate from us, like just like a microscope is a function of its physical components, so too is the human eye and our capacity to see subtle particles a function of our components, which is the atoms, what we call atoms. But really, they are iterative fundamental particles that occur across scale that have importance, and like these discrete things happen, not just in atoms, but in many ways, like how supernova type 1A or 2A. Supernova type 2A. 1A. Yeah, this one always releases the same amount of energy when one star absorbs energy from another, where one is a white dwarf, so that it is used as a standard candle. There we go. Because then its energy is consistent and its distance can be measured with reliability, since we can't just like simply use trigonometry to determine how far away a galaxy is. So we need some kind of standard candle that provides a method of like triangulating these systems and what's really how far they are. So when we see a supernova type 1A, it's used as a standard candle because it is considered, at least, to always release the same amount of energy. I guess that amount generally. And so do reactions, like a chemical reaction, because it's the same process, just across scales. We're literally living inside of atoms. We're surrounded by them, where we see them performing their functions. It's just that we haven't related them directly yet. So, let's talk about this, I guess. See what's up. I don't know. Before this, actually, maybe it's worth noting, when I saw this, I thought, I wonder what this guy on Twitter, who I know is on Twitter, might have said about this. This author, who's one of the authors with the Corto et al., deeply involved with that team of people, which I believe includes these guys. And this paper is really fascinating because they found a structure which I've mentioned in the past, but I couldn't find him talking at all about this new structure. It's very recent. I don't know if he has come across it. I imagine he's heard about it. I'm surprised he hasn't posted about it on Twitter. But they have named it Ho'olailana? This Hawaiian name. Billion light year wide bubble of galaxies. So let's find this. Centered on the Boots supercluster. So, and let me find the discussion. Although this sphere thing was identified as a 2D feature, a significant component of the signal comes from the foreground part of the 3D shell. Parentheses. The backside far edge falls slightly beyond the redshift z equals 0.1 limit of our sample. So I guess let's see. Where's this structure? It's down, isn't it? I guess this is Earth. Literally a fractal system right there. Okay, so where is this though? Go back. Okay. Remarkably, the Coma Cluster, the Center for Astrophysics Great Wall, and structure coursing up to the Hercules Supercluster lie along the foreground surface of the posited baryon something to do with baryon oscillations or something, acoustic oscillation surface. So let's just real quickly kind of read this to get an idea of what they're doing. Theory of the physics of the early hot universe leads to a prediction of baryon acoustic oscillations that has received confirmation for the pairwise separation of galaxies and samples of hundreds of thousands of objects. Evidence is presented here for the discovery of a remarkably strong individual contribution to the baryon acoustic oscillation signal at z equals 0.068, an entity that is given the name, that one. Radius is 155 megaparsecs. I don't know what this means. At its core is the Boots supercluster. So this thing has a core of a supercluster. The Sloan Great Wall, and the Center for Astrophysics Great Wall, and the Hercules complex all lie within the shell of this thing. The interpretation as a structure with our preferred analysis implies a value of Hubble constant. Okay. Because Big Bang is very important. Okay, so these things lie along the foreground surface. So to me, like, thinking of it as like a planet, literally like planet Earth, having like some types of major current flow paths that maybe aren't like rivers, but like structurally places in the earth where major amounts of currents flowed. It makes me think of maybe the super plumes, that kind of places where they concentrated though. Maybe those are more like galaxy clusters where there's constant super plumes where the current is concentrated. More of like an equatorial belt maybe, and is where like currents are flowing that have a bunch of eddies just one after another, which would be a string of galaxy clusters, a bunch of eddies strung together one after another. It makes me think of like around the equator. Like if we look at this one, doesn't have them both. Where is it? This one. Eddy, and then a larger scale structure, eddy over here, eddy here. But there's also an eddy over here. There's probably more eddies in here that are not as apparent. And then over beyond this were more eddies on North America at the Gulf of Mexico. Dude, it's in too many freaking papers, and it's too irrelevant. But, let me see. Some eddies here, some more eddies. So there is a tendency for eddies to occur like this on the surface when the flood was happening. And then it has let's keep going. The famous Boots Void lies within the embrace. So there is a void. Boots Void. Approximately spherical region of space containing only 60 galaxies instead of the 2,000 that should be expected from an area this large, hence its name, with a radius of nearly 330 million light years across. The Boots Void is held in the embrace of this thing that's extremely spherical looking. So the spherical void is held inside a spherical looking thing. I don't know, it just makes me think like maybe I can just quickly here's one looking like it's got a equatorial, curious, less erosion there. Huh. Oh yeah, let's look at rocky boulders. Boots Void. Center for Astrophysics Great Wall or whatever. Sloan Great Wall. Like literally, I'm not saying that exactly like paralleling, but Rocky boulder. Wow, that thing has a freaking flat, rounded edge here. It's in fucking out of this world, dudes. There's gotta be some better images, though. I know I have found better images on YouTube videos. Broken, I guess. That's probably better. I mean, they all kind of look like that, I guess. Just imagine the entirety of everything we know is in like a grain of sand right here, and we're just hanging out, and we can see like maybe this far, and then this system just overwhelms everything, so it's like influencing things beyond that, so that we see things that we think beyond that are like illusions that this system has lensed into being by having like influencing the light from nearby grains of sand, emissions from them to like flow through this, and then just to arrive at our grain of sand, our solar system, and be like, oh, there's all this stuff going on, but it's like a product of this system's illusions. I'm not saying that this would exactly be doing it. I mean, it's probably not quite the circumstances we're seeing, but this here is the zone of avoidance, I think, where we can't really see stuff very well due to the galactic disk of the Milky Way. So there's this thing centered on the boots, super void, and this boots super cluster, that it has physically large scale other structures as part of its shell, or maybe like mountain ranges. Something I think about is like a mountain range where there's just like a chain. Oh yeah, so how big was this? I believe it was 1 billion. Yeah, whatever. believe is a billion. I think if I just go a spherical shell-like structure 1 billion light years in diameter, with the center Boots supercluster and the Boots super void or whatever were generally centered. I'm not sure how they're both centered. If the supercluster is within the void, I don't think so, but maybe. Laniakea is where all this other stuff is, where Earth is. Crazy. But a billion light years with a 333, so about a third of the radius, void inside of it thing that looks kind of spherical. And then there's this back to this paper, Unveiling the Largest Structures. So that was a smaller structure, I guess. Largest structures in the nearby universe. For a precise determination of cosmological parameters, we need to understand the effects of the local large-scale structure of the universe on the measurements, such as gravitational lensing, influencing things beyond what we realize, because there's large-scale structure that's there, like a huge frickin' sun type thing that we see like here. This huge system, a billion light years in radius or in diameter. If there were such a system, it would probably influence our measurements, maybe even overwhelm our measurements if we weren't paying attention and realizing there were such a system and accounting for it. They include modifications of the cosmic microwave background, distortions of sky images by large-scale gravitational lensing, and so maybe even larger scale, though. Like, all things are relative. Something that's large scale for, say, Earth's capacity to gravitationally lens is much smaller, but it still can gravitationally lens large scale relative to certain instances if light is like further away from the Earth. So same it goes for like something that's really super massive. It could make something that generally is seen as large scale to be more subtle and like not really the same process accounting for like the large scale. And the influence of large-scale streaming motions on measurements of the Hubble constant. The streaming, which is just a constant focus in modern physics because we think expansion of space is a thing. The streaming motions, for example, originate from mass concentrations with distances up to 250 million parsecs. In this paper, we provide the first all-sky assessment of the largest structures at distances between 130 and 250 million parsecs, and discuss their observational consequences using X-ray galaxy cluster to map the matter density distribution. So they use X-rays of galaxy clusters to determine the density distribution of matter. Okay. Yep, that's what it said. Among the 5 most prominent superclusters found, the largest has a length longer than 400 megaparsecs, with an estimated mass of about 2 times 10 to the 17th masses of the Sun, solar masses. This entity, which we named Quipu, is the largest cosmic structure discovered to date. These superclusters contain about 45% of the galaxy clusters, 30% of the galaxies, 25% of the matter, and occupy a volume fraction of 13%, thus constituting a major part of the observed universe. The galaxy density is enhanced in the environment of superclusters out to larger distances from the nearest member clusters compared to the outskirts of clusters in the field. We find superclusters with similar properties in simulations based on the lambda CDM cosmology models. We show that the superclusters should produce a modification on the cosmic microwave background through the integrated Sachs-Wolf effect. Searching for this effect in the Planck data, we found a signal of the expected strength, however, with low significance. Characterizing these superclusters is also important for astrophysical research. For example, the study of the environmental dependence of galaxy evolution, as well as for precision tests of cosmological models. Okay, we made it. Okay, we did it. We did it now. Introduction. Large efforts have been invested in the study of cosmic large-scale structures with the main motivation to test cosmological models. Okay. Let me kind of go down. So what they found, we can maybe go to discussion or conclusion. Here we go. With our search criteria, we found 5 superclusters in the redshift region of 0.3 or 0.03 to 0.06. With the same criteria, we found only one such structure in the local volume. The target of this study is 8 times larger than the local volume. Well, the number of 5 superclusters, or superstructures, falls slightly short in comparison. The number of involved clusters are with 155 for the target volume. I don't know what they're talking about in particular. Let's move past this kind of just like this is how we did it kind of stuff to more so results. Another cosmological volume analyzed for the presence of large structures is the Sloan Digital Sky Survey. Largest structure found there is the Sloan Great Wall, 328 megaparsecs. Studies of the topology of the large-scale structure in cosmological simulations have shown that large filaments with a size of greater than 100 megaparsecs dominate the cosmic web, since a redshift of about 2, carrying up to 50% of the total mass of the universe at present. I believe it means after a redshift of about 2, so above a redshift. I don't know about since the word since is because of the time element of high redshifts, to a point where it's become considered a time in the history of the universe, so that it would actually be written as since, as opposed to above a redshift of 2. That's freaking kind of fascinating. And it just shows how modern science is flawed. Because that's the lingo, but it's obviously above a redshift of about 2. No offense, guys. This is the lingo that is happening in these papers commonly. It's not exclusively here, but where it becomes spoken of as time because of this actual acceptance of the Big Bang as fact. Acceptance of it as fact. So then redshift is 2 is a moment in time, biblically. In the doctrine of the Scientology, not Scientology, but Scienceology, whatever. In the doctrine, there is a time that equals Z is 2. we can identify these structures with the so that to me, what I was thinking is, well, if light is arriving at Earth by traveling like, here's this object that says is centered on the Boots void, if it's that thing. Here's Earth over here, and light is traveling and being redshifted as it's traveling. But really, I'm drawing it poorly. It's probably more so going like this. More so with like just like a magnetic field, but like having a flow that's like polar, pole to pole through this system. That's just what happens when the rotation is happening, and it's influencing the subtle particles to flow in that way. So then it perhaps my thought is, imagine light then comes out here. Is it gonna come out of here and just disperse evenly, or maybe it kind of starts to interact as it passes through, and then like this one is kind of supercharged over here, and like this one is supercharged. But like this one maybe is not as strong. Something where there's actually like preferred paths, discrete paths, that it literally etches through a matrix kind of behavior to then yield higher flow rates through certain conduits, which then, like literally this vibratory thing, like a shallogram, where like eddies can happen off of it, like going back and around and eddying in here. Maybe this way, off of it this way, eddying in here, off of it this way, like as it's flowing this way. Eddying, I know this is two-dimensional, so it's not the best, but I'm doing my best with what I got, etc., so that there's a tendency for galaxy clusters in a larger scale system to form in chains that then or not galaxy clusters, but like the observed interactions of the light passing through the system makes it look more like they're like actually interacting and near each other and being a galaxy cluster, although there's certainly anomalous observations that have been recorded that I've mentioned in the past, where like things that should be interacting gravitationally don't appear to be, according to the technical research papers, where they like look at the data and know what they're doing enough to figure out like these are not seeming to be interacting with each other, but they seem like they should be, and then just kind of move on from it. But like maybe because they're illusions next to each other, brought together by the flow of the currents of the light, so that after two redshifts, it tends to turn what we see into filaments that isn't quite realistic because it's an illusion. Or it's not an illusion, I don't know. I'm still not completely certain, because these large-scale structures seem to suggest otherwise. Unsure. That's why my research in this regard is kind of like, what to do. What is the issue that I could try to figure out exactly what the issue is. I know there's an issue with my research and with regard to specifically all distant redshifted galaxies and my interpretation and that the light is traveling in a magnetic field kind of shape, which takes gravity and explains another fundamental force substantially, which is the whole freaking point of physics. So it seems like it's a pretty solid argument, so it should make sense since it does provide an actual mechanism for redshift without adding expansion of space. It should provide explanation for the large-scale data if it's considered. It's just there are in anything, there's anomalies unaccounted for that need some adjustment to the interpretation. And in this case, I just haven't reasoned it through, so it's kind of still like a open question in my mind of what exactly is going on the large scale. Like, these structures seem to exist, but that doesn't mean they do. Or they do exist, but then it's within the redshift data. That's why I lean towards they don't exist. These are observations within the redshift data, which is almost certainly not a product of expansion of space and is instead a product of gravitational lensing of a single system influencing all the light from all galaxies so as to redshift it in a manner where it actually is correlated. Hubble's law, which by the way is called a law even though it's a correlation, that was initially observed to be linear enough that it was called Hubble's law and given Hubble's constant, but then it's accelerating, so I guess expansion of space is accelerating, even though actually the correlation is not a law. That's what's happening. It was never a law. It was just a correlation. Silly. But anyway, solid lines show the result of the total blah 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 blah. I don't know what that was. Just kind of jumping in there and realizing I was just jumping in there. Let's see the conclusion. In this study, we characterized 6 large superclusters with more than 20 classic galaxy cluster members in the nearby universe out to a redshift of z equals 0.06. That's pretty small, which is a good sign, really, because as z gets higher, that's when the structure would be not actually mattering, not actually visible. What we see would be much more illusions, because imagine this system is large scale of a galaxy, a galaxy of galaxies, or a galaxy of galaxies of galaxies. It's so far up the frickin' line that it's composed of galaxy clusters as just portions of it. But where it's equally spaced to its adjacent galaxy, so the next nearby one is fucking far, so it's probably hard to identify if we can even see that far with our technology. So we might just not be able to really see beyond this system, and so what we would then be able to see would be the local universe, including the system within the data. But then somewhere beyond that, where redshift becomes all red, Every galaxy we see beyond a certain distance only is redshifted. I don't know what that redshift is. At what distance are all galaxies redshifted? I mean, it can't be very far from where they're looking because it's probably z equals 0 or 0.01 or something is where they kind of begin the distance measurement. The only supercluster found in the local universe z less than 0.03 with these properties, the Pisces supercluster, has been described earlier by the authors. For the present supercluster construction, we only included clusters with an estimated minimal mass of greater than 10 to the 13 solar masses. This is only important for low redshift, since for higher redshift lower mass clusters are not included due to the flux limit of the sample. Okay. The largest structure ever detected, Quipu, with a length of 428 megaparsecs. .4 billion light years. Let's put it into billion light years. .4 billion light years, okay. Clearly apparent in a map of the cluster or the galaxy distribution in the redshift range, the highest concentrated mass over density in the target volume of our study is found in the Shapley supercluster, closely related to the Great Attractor. Are they the same? I can't remember if they're... Oh, yeah. Okay, so the highest concentrated mass over density of this structure is found at the Great Attractor region. This structure has been made responsible for a large part of the gravitational pull that causes the peculiar motion of the local group with respect to the CMB frame. You know, like a galaxy center does, causing things to orbit it relative to its surroundings. We showed that the galaxy density in the environment of galaxy clusters and supercluster structures is significantly higher than around field clusters. This characterizes superstructures as special astrophysical environments. We also showed that these structures should leave a signature in the CMB through the integrated Sachs-Wolf effect. Property of the cosmic microwave background in which photons from the CMB are gravitationally redshifted. So they're saying where was that? We also showed that these structures should leave a signature of gravitational redshift in the CMB in the CMB, comparable to the cosmic density fluctuations in the background. Searching for this effect, we could only recover a signal with a significance close to 1 sigma, but with the expected strength, which is another part of my video here. The cosmic microwave background is somewhere in here. This one, the dipole, cosmic microwave background dipole. Which very likely relates to what they're looking at off. A little surprised it doesn't like come to mind, those, because there's literally these dots. Look how CMB dipole images. Okay. Okay. Interesting follow-up research on our findings includes, for example, studies of the influence of these environments on the galaxy population and evolution. In our earlier paper, Giovanelli and co-workers show the galaxy distribution of different galaxy types in the Pisces supercluster. In their figure 6b, we can see a very sharp image of the filamentary structure of the supercluster on a 100 megaparsec scale traced by early type galaxies. This is very different from the outline of the supercluster by other galaxy types. Detailed studies of the large structures described here may show a similar effects over even larger scales. Similarly, the dense environment and the large fraction of the volume heated by accretion shocks in superstructures can, for example, be expected to have an imprint on the entropy structure of galaxy groups. The dense environment and the large fraction of volume heated by accretion shocks in the supercluster. So due to a dense environment having shocks from all the heat, can be expected to have an imprint on the entropy structure of galaxies. Thus, X-ray studies of galaxy groups in superstructure environments compared to observations in the field could shed new light on the formation of intracluster medium. In the future cosmic evolution, these superstructures are bound to break up into several collapsing units. They are thus transient configurations. We interpret completely without any way to test this because it is frozen in time. But at present, they are special physical entities with characteristic properties and special cosmic environments deserving special attention. So, let's find this image. There's that one. Density map. So where's the number? The number as they appear in table 1 overlapping structures of 3 and 4 just carry the label 3. So there's 3 and 4 over here. 1, 2, 3 and 4, and then 5. And I don't know what this is about. Let's see. I don't. Whatever they're called. There's the structures. I'm not sure. It's very hard to pinpoint where the great attractor is. Let's see. Great attractor. Shapely concentration. Centurus cluster. It should be over here in this area. Boots super cluster is up here. I guess I could click that. So we got Shapely CMB dipole. Whoa, it's like the boots void is at the pole. If this is some kind of structure, I don't think it's a structure. I don't think it's a void either. I guess it's observationally restricted by the galaxy somehow to yield that shape. I don't know what the heck is going on with that. No. The members of the supercluster outside of the target redshift range are not encircled by a black ring. Open circles in the zone of avoidance. Solid blue lines encloses the region with an interstellar hydrogen column density greater than oh my god. What the fuck? Shit's incredible. Shit's incredible. I think I need to play a different playlist because it went to potentially copyrighted music. I'm not sure. This one looks fine. Interstellar. Like, what the fuck? Oh, okay. It's interstellar as in the Milky Way. The density of hydrogen. So, like, there's restrictions to our capacity to see through the region, I guess. Or maybe even the hydrogen helps. I'm not sure. I don't know why it would help, but survey covers nearby objects more completely than any other X-ray or cluster surveys. Cluster sample that was previously applied to cosmological studies and is used here was compiled with the above given flux limit and the requirement of at least 20 source photons. Crazy. Connection of the cluster distribution with the underlying matter distribution. I don't know. So the great attractor, I believe, would be over in this area somewhere. Let's see, table 1. Shapely 2. I'm just like, could it be a galaxy? Let's look at some galaxy images. Maybe put in Messier just so it's real. I'm just thinking like this kind of thing. Maybe multiple from some kind of system. I don't know. I don't know. Okay. That's all I got for now, I think. I mean, I could certainly just babble on to myself probably forever and eternity. What a sad life this was that no one ever cared. Ever, ever, and ever. Future just mocks it. No, future doesn't even know about it. It's just life. It's life, dude. Break the game. No one knows. Did you break the game? Shoot, I guess not, huh?